Okay, so um, I'm back with my. Uh, I have a couple of good news to share. Um, the first thing I would say that I remember the in the last videos I was pretty much worried about my like category O and highest weight category course. Well, the exam was oral, and there is a good thing about it and bad thing about it. I mean, the oral exam itself. Uh, I wouldn't say it's a bad thing necessarily what happened during the oral exam. The first thing that I was uh, slightly, I would say, disappointed about the oral exam is that my potential supervisor wasn't there back then. Uh, I wouldn't even say that. I wouldn't even say potential supervisor because I was pretty much nobody to her, in my opinion. The other thing is that oh shit. Um, the other thing is that well, uh, I mean it's a good grade. In German system, I got 1.7, which is pretty decent, I would say. Uh, but I would say the grading was fair. There's no denying and ranting about uh, it was a little bit too harsh or something like that. I would definitely say that the questions were pretty fair, and I froze during the oral exam, and I couldn't answer some questions that I would answer without without any problem. So if I'm relaxed or something like that. And the good thing about the oral exam is that uh, I would say that I did pretty well for the category O part, which is just about Lie group, not Lie group, Lie algebra specific parts. For example, I was asked about uh, translation functors a lot, which is kind of hard if you think about it using some abstract notion. So, for example, what is the definition? It's like if you are going to translate from say to lambda to mu, it's going to be project to mu of the module that you are interested in, or I should write like this. Tensor it with a simple module. I'm not really sure about the sign here, but it doesn't really matter. Like, uh, it is not so important. Like your usual. I would say it might be important, but anyway, in my impression, like this abstract definition is quite hard to deal with unless you are building the very basic the facts about translation functors. From the point of view of visualization, it's very easy. I will draw the case of SL3 because I mean these are the best in my opinion to think about the translation functors. If we have some module here and you translate it to it, then you get something, right? And um, suppose suppose for concretely, like if you are dealing with category O, you are generally interested only about this uh, special modules. I will not talk about tilting modules for now because they are, I mean, it requires pretty much uh, like it is a less intuitive in some sense than uh, projective, simples, or Verma modules. I mean, there are some nice cases in which they coincide. For example, in this minus rho case, this is a like in minus rho orbit, the tilting module is just Verma itself, like because you have only one isoclass of modules. But regardless, if you are talking about Verma module, let's say it's just regular weight lambda, then you translate it into weight at the wall, then you get another Verma module. And really interesting part about this thing, in my opinion, is that this was a really great drawing. Like I got a triple crossing at one point. So if you are already at the wall and you try to put pushback into the regular weight, then what you get is actually like I would say that it is something like superposition of it. So what we get is something like uh, how should I call it? Let's call it S wall, and I will just put S stat lambda here. And because from the definition, so from what I've drawn, I think you can see that uh, this weight is great. Like the original lambda is greater than the weight which is S dot lambda, and we have some non-split exact. I will label it 3, 2, 1. You get non-split exact sequence 3, 2, 1. I mean zeros at the end, but it's not that important. Usually people tend to write in some cases like this. Yeah, using the injective arrows and surjective arrows, and yeah, I told them what I think about what I intuitively think about Vermas and simples and how they behave, and they were quite happy about it. That I can argue about abstract Verma module properties or projectives or simples without actually going through the definitions and computing nonsense extension groups. Like if I were to be told, then I can probably do it because I know some facts like how Verma flag could behave. Like for example, if an object has a Verma flag, then you can translate it and it will have some special properties. Like you can just treat it as Verma modules, pretty much. Yes, what I was trying to say is that, well, yeah, I pretty much nailed the category O part, and the gaps actually came during the highest weight category part, which is the second part that I fear the most, and it is about something like. For example, it's an abstraction. For the case of category O, like category O is an example of a highest weight category. And what happens is, the theory of category O builds upon Verma modules. Like Verma module is something we can compute and construct very easily. But how do you everything built upon Verma modules. So the gist of highest weight category, which is due to Klein partial Scott. Scott's paper. I don't know. I don't remember the paper name as of now, but they have several papers. I think it was the name itself contained the the word the highest weight categories. Oh, I forgot T here. Anyway, so what happens is for the highest weight category is that we try to abstract, make it more abstract in a sense that in category O we have nice modules called Verma modules, but for highest weight category, like it is an abstract nonsense in some from some, well, in my opinion, like it's not that important. But I mean, it's definitely very categorified. Or I mean, I wouldn't say categorified, but everything is about categories here. But I mean, it's a abstract reasoning on categories, I would say. And what happens there is pretty much like we have Verma modules, uh, and we take Verma modules into so-called standard objects. And dual Verma modules, it's not just a naive dual, because if we take naive dual, we have some problems with it. We define also so-called costandard objects, and we reason about the structure of other modules, depending on the Verma flag analogs, which I personally call it standard flags and co-standard flags. But I guess in many sources, its preferred way of saying it is standard and co-standard filtrations. But I mean, I personally view it as flags, so it's not. I mean, it's pretty much interchangeable, I guess. Like if I say standard flags, everyone knows what I'm talking about. If you know what is a highest weight category, uh, does what does highest category, highest weight category, and what else? Yeah, and the professor, the one of the professors, asked me what is well, I mean, the definition was pretty much easy, I would say. Like I got asked something like, uh, how do you define highest weight category, which is kind of easy. Like you just define um some poset, and the maps that uh the maps that generate iso classes of simples in the category that we are interested in, and then under the image of posets, poset lattice. I just call it weight, whatever, but it's not strictly speaking weight, but yeah. And he asked, what happens for category O, and what I said, well, it's just an example, and he said something like, let's talk about Ringel duals and Ringel duality, and he said, like, what is a Ringel dual of category O, and is this some kind of monstrous thing? Like, the formulation of Ringel duality requires some abstract nonsense as well. Like, you need to check if the like it is I know it as a fact that uh, for example, finite abelian categories can be is categorically equivalent to finite dimensional uh, A modules. Some for some algebra A, specifically, it should be something called quasi-hereditary algebra to make it uh, like for it to be like, for example, if you have an algebra and you consider finite dimensional modules over it, can you find the corresponding highest weight category? The answer is yes, if you have A as a quasi-hereditary algebra. And if we have such kind of fact, then we can construct some nice duality, which is called, well, Ringel duality, as you might have guessed by now. And Ringel duality provides us with some interesting notions. Like if you take the Ringel dual of the tilting module, then you get projective, and you can using it compute some standard and costandard multiplicities. And yeah, that's how I think about. I wouldn't say I think about tilting modules that way in some sense, but I can compute definitely Verma or Verma flags, right? Or should I say no? Dual Verma flags on on tilting modules, because if it apply Ringel dual functor to that, then we get tilting maps to projective, then and cost dual Verma to standard to Verma, and we know what it means to have Verma multiplicities of projective objects in category O. And he asked me something like, "Do you know how to prove that category O is a self-dual?" I mean, I told him that. Well, I mean, at least for principal blocks, that's all we need actually to know what is a Ringel dual of category O. And he asked me if I know anything about if I know anything how to prove category O is a Ringel self dual, and I told him no, I don't remember it, and I got my 1.7. I would say that it was pretty fair. So yeah. And another good news is that I think I found my supervisor. So this was actually my very first representation theory course in my life. Not in my life. I had a course during my undergraduate studies course called Lie groups and introduction to representations, I guess, and it's not that important. That like the name itself is not that important. But what happened is we pretty much discussed only the matrix 3D groups, which I think it's very helpful in getting introduced into Lie groups, Lie group constructions, and all that kind of things. Um, yeah, besides that sort of introductory representation theory course, which I wouldn't even consider it to be representation theory, but I mean it's Lie groups, so I might consider it. Oh, but anyways, the supervisor probably noticed my potential supervisor probably noticed that I don't have any background in representation theory at all, and she might have been a little bit reluctant to accept me before I complete her course. Uh, yeah. So what happened to the supervision topic? It's pretty much straightforward, I would say. Like, I got introduced to three possible thesis projects, and I can approximately I can probably approximately talk about it because I mean it's a pretty much common knowledge, I would say, for those who are interested in this direction. It's about something about KLL algebra approach, and the second thing is uh, about operads and combinatorics. And the third one is about some specific quantum group. Um, she repeatedly told me that I need to choose something that I like. Well, that was, I would say, a pleasant surprise to me because when you read when you read about how thesis goes, or like research assistantship under supervision of professors, like usually go. I was ready for the worst case. Like I wouldn't. like from the lectures, I wouldn't even consider, like I would end up in a worst case, like just seeing my professor, and she didn't look like someone who would uh, do something bad to her students. But anyway, uh, because I she repeatedly said to me that like the only the only criterion that she considers her students, like as thesis students, is the fact that if a student enjoys the math involved, and because of that, I am very pleasantly surprised at how many times she repeated that the only thing that she considers like absolutely required as is that if I'm interested in something that I will work on for the next 12 months. Not necessarily 12 months, but I should submit it within 12 months from starting. And I mean, this is solid, and this is solid. And I could immediately see that. Like, this is a KLR, the Kovanov-Lauder algebra approach, which is kind of very frequent name that you see when you study something related to algebraic representation theory, I guess. And this is quantum groups also sounds very solid. And from the project description that she gave me, I mean, I cannot. I'm not really sure if I can share it with you because if I end up not taking it, then I'll probably that project might be transferred to another potential thesis student. So, I mean, I would prefer to not cover the details of it. So, I mean, this two first and third project sounds very solid and impactful, and we have some kind of immediate visibility in some sense. Like, I mean, if you do this kind of things, then it just sounds solid. But um, I think she noticed that I'm not that interested in the first and the third one. uh, I got interested in the second one, which I in my shallow knowledge is not so mainstream. And yeah, I think I'm gonna take the second project. My professor is out of office for the next 2 weeks, so I will probably read about Operads and yeah, just study it. And the reason why I think that she will be supervising me is that, well, she told me what she expects for a thesis student, like before this meeting that happened about 3 or 4 days ago, and when I approached her, I was told that um, it is very much possible that she will not be supervising me, but by someone from her group, which I consider to be totally okay as long as I do something that I enjoy. But uh, now I'm given option to have both. Like I can do something what I enjoy in math, and I can get supervised by the professor I admire. Yeah. So that's pretty much it. I would say regarding supervision session. Yeah. So I expect to be supervised by her, but it is totally okay if she changes her mind last minute and uh, I I get a the supervision by anyone in her group. As long as I do this second project, I guess. Uh, I I didn't study that much, like because I didn't have time and I was out of exam and I was quite tired, I would say. But anyways, like I'm totally okay with anything uh, that is involving this second project. And besides that, what do we have? Yeah, also, I have two exams coming up pretty soon. Uh, Not pretty soon, in 1.5 months, I guess. But anyways, Rep Theory 1. This is about these compact Lie groups that I think I shared one specific exercise, if not two or three. And something that I need to cover to graduate, uh, scientific computing 2. And yeah, I'm just hoping to survive those things. I mean, the Rep Theory 1 would be slightly easier, but it involves quite a lot of these matrix coefficient things that I personally didn't enjoy that much. And scientific computing, I mean, mm, this weak derivative and weak solution formulation is not so pleasant to me, but I guess I have to deal with it somehow. And for the next semester, I will be dealing with some specifics of a specific seminar. Oh, semester and seminar. So I will take a seminar that I will present web calculus for SLN. I cannot wait to start studying this because it just turns out that the combinatorics specifically involved with operads that I'll be studying for my thesis is heavily related to web calculus. I mean, I just picked it without thinking that much. Like I just know how webs looked like, but I'd never studied it formally. But this web calculus thing will be actually uh, quite helpful for operads and combinatorics parts of my thesis. So it just turns out that I'm extremely lucky and I'll be doing something related. And I will take two more classes, but it's not that important, I guess. So that's pretty much it for today. And I will probably continue uploading uh, study sessions of for those two exams. For operas, I just feel like that I might just misinform you completely. So I will not be making probably a daily videos on operas, but I will definitely write some and take video of some math my math journey, I guess.